All right, so we're back to this slide for a second. Just for the purposes of completion, since you can see the crosstab in this digital format on all these slides, here it is with the expected frequencies filled in. So you can see we have the observed frequencies, which are the responses we actually have in each category, and then the expected frequencies, which are the frequencies we would expect if there was no relationship between these variables in the population. And we're going to be using that to perform what is called a chi-square test. As in any hypothesis test, our first step is going to be to come up with hypotheses about what's going on in the population. And as usual, when using this class data, we're going to pretend that the population is just criminal justice students at Rutgers in general. And we're going to once again pretend that you guys are a random sample of this population. Not actually a random sample, but for our purposes, we're going to say that you are a random sample of our population, and we can generalize what we learn in this class to Rutgers criminal justice students as a whole. So the chi-square test is all about whether or not there's a relationship between two variables. And the hypotheses for a chi-square test are always going to have this format. Your null hypothesis is that there is no relationship between two variables. In our example, our null hypothesis would be that there is no relationship between gender and having been in a fight. In other words, knowing somebody's gender will not help you predict whether or not they've been in a fight, and knowing whether somebody's been in a fight will not help you predict their gender. So that null hypothesis is that there's absolutely no relationship between these variables in our population of interest. Your alternative hypothesis, as usual, is the exact opposite of your null hypothesis, and the exact opposite then is that there is a relationship between these variables. So if we reject our null hypothesis in a chi-square test, we'll have evidence that is against the idea that the variables are not related, and it can be interpreted as evidence in favor of the idea that there is some relationship between these variables. The next step in the chi-square test is to calculate the test statistic. And the test statistic in a chi-square test is something called chi-square. So chi is a Greek letter, chi-squared is a squared Greek letter, and it looks like that right there. The chi-square statistic is a test statistic just like Z or T or F, so like all the other test statistics we've met so far. And so it's a statistic that's based on our sample data that will allow us to place our sample that we got in a sampling distribution and tell us about how likely or unlikely our sample is. And what the chi-square test, what the chi-square statistic reflects is how different the observed frequencies are from the expected frequencies. So what you saw on this DocCam a second ago is that the frequencies we actually saw in each cell were a bit different from the frequencies we would expect if there was no relationship between the variables in the population. What the chi-square statistic, bang my head against the table here. What the chi-square statistic tells you is how different those observed frequencies are from the expected frequencies. And we're not going to go through how to calculate it. It's one of those things that's, I think, doesn't really add to your life to know, as long as you know what the statistic means. And so again here, the statistic just reflects how far off what we actually see is from what we would expect to see if there was no relationship in the population. So how far off are the observed frequencies from the expected frequencies? And so the chi-square statistic is larger when the observed frequencies are more different from the expected frequencies. So the further off your sample is from what you would expect if there was no relationship between the variables in the population, the bigger the statistic is. And then the more similar your sample is to what you would expect, the smaller the statistic is. And then we're going to place this statistic on a sampling distribution like we usually do, use that to calculate a p-value, and use that p-value to decide whether or not to reject the null hypothesis. And as a quick note before I go into the document camera and do this, this test only works if the expected frequency is at least 5 in each cell. So if you ever encounter one of these and you get an error message or you come up with an expected frequency that has less than 5 cases in each cell, then you have a problem because the test isn't really reliable anymore. So that's something we call an assumption about a statistical test, where we're saying we can only trust this if, X, Y, and Z is true. So in this case, we can only trust the results if there are at least 5 expected cases in each cell. All right, so with that, we're going to go back to the document camera, go through an example of the chi-square test, and then come back and talk about correlations after that.